We added electric vents, but my dispatch board still assumes every truck starts full. How do I know this EV can actually finish the route? That's the exact problem this video is about. Field service companies are starting to electrify their fleet. Maybe it's 2 electric vans this year, maybe it's 20 next year, and everybody knows this is where the future is heading. But the dispatch side is still kind of stuck in the gas world. With a gas van, your dispatcher can be a little loose. If the route is long, the driver can fill up on the way. It takes 5 minutes. The dispatch board doesn't really have to understand the fuel. With an EV truck, that's not true. The battery matters. Where the charger is, it matters. Whether the truck starts at 100% or it is starting at 32% matters. So your dispatch software doesn't really, if it doesn't know this, then one of the two things can happen. You either underload the electric trucks to be safe, or you schedule them like gas trucks, and eventually someone gets the call nobody wants, which is, hey, the truck cannot finish the day. That's why we built EV aware dispatch inside FieldCamp. The way I think about it is simple. Your dispatcher shouldn't guess whether an electric truck can take one more job. The system should know. In FieldCamp, gas trucks and electric trucks can sit on the same dispatch board. But when a technician is marked as an EV, FieldCamp treats the battery as a real planning constraint, not a note, not a color label, a real constraint. And let's just say we have a mixed fleet, a few gas vans, one electric service truck, and a dense day of jobs. The EV truck that starts morning at around 35%, because that's what happens in real life. You forget to charge, trucks don't magically start every day full. In a normal dispatch board, the truck might get still assigned a full route. So to avoid that, we have solved this problem in few ways. So what you're looking at on the screen is the EV charging station screen on FieldCamp, where if you see the solver routes EV trucks to these stations when their range is tight. We auto discover, which is very important, because when most dispatching, when it is planned in advance, it misses this step because there is no live data that is coming in from the site. How FieldCamp works is FieldCamp is pulling live data from the site using the AI Dispatcher's mobile app and something which is called Smartcar. Smartcar mode is we integrate with Smartcar, which you can install on your electric vehicles. When it is integrated, it tells us live how much battery is remaining in that truck or in that car, whatever vehicle it is. Once you know that part, the second thing is when you are making a full route in advance, you have to know based on current battery percentage, which is 35%, it can go to the first stop. The next second stop should be a charging station. So how do we know which charging stations? We use another integration which is OpenChargeMap for that, where you can auto discover what chargers are available in your area, or you can manually even add a private charger which you can name, what's the address of it and what's the power of it in kilowatts. And if you want to add type, if it's DC fast, level 2, etc., you can add a private charger as well, or you can make it your private depot or the home base. If some technicians have a home charger installed, then that is also an option which is available in the FieldCamp system. As I said you, FieldCamp looks at the route very differently. It knows the vehicle profile, it knows the battery capacity and consumption, it knows the live starting battery if that vehicle is connected through Smartcar, and it knows the minimum battery flow. So if you tell FieldCamp, do not let this truck go below 20%, that becomes a hard rule in dispatch engine, and that matters. Most tools will show you battery, that's useful, but it doesn't solve the dispatch. A dashboard can tell you this truck is at 35%. It still gives you a figure out which just means for like you to pretend how you will plan the route. FieldCamp plans around this. Now before we optimize, we need, as I told you, in this fleet, I have few team members and few crews which are doing things like in a manual gas truck, and few who have EV powered fleet. As you can see over here through the Smartcar integration, we know for instance how much battery they have remaining in their particular vehicle. Not only that, when you add a new person, for instance, you can enable the EV truck routing, and over here you can say what type of EV car or vehicle it is. If it's a Ford e-Transit, if it's a Ford F-150 Lightning ER, it's a Rivian EDV, It's a Bright Drop, Mercedes E-Sprinter, Bright Drop Zevo, Tesla Model Y, Tesla Model 3 long range. Whatever vehicle it is, you choose one of the vehicles. If you want a custom vehicle added over here, we can add that as well. What's the battery capacity of the vehicle? Energy consumption kilowatt per kilometer, minimum battery safety floor, and then target charge on detour. Once you add all of this, you will connect your smart car to FieldCamp. So once you do the smart car integration, FieldCamp can get live data on how much battery percentage is remaining in that particular vehicle. Once all of this is set up, you have all your crew set up. As you know, in FieldCamp's AI dispatcher, you can add all your skills of what type of work each technician or crew can do, what type of jobs each technician or crew can do. So you can watch initial AI dispatcher videos if you want. But once the basic setup of team is done around the EV constraint, you've added all your charging stations where the technicians are allowed to charge. Then comes the next step. How do you actually plan the day and use this data? So now FieldCamp has what it needs: the jobs, the technician, the real battery, and the charging network. Now we run the dispatch. This is the moment that matters. If electrical truck can complete the route while staying above the safety floor, FieldCamp schedules it like normal. But if the route would dip too low, FieldCamp sets a charging stop, and on the list you will see it as a detour. So once you approve it, the driver or the technician will know that, hey, for this work, before we started, we need to go take a 30-minute break and charge the car. So now if you see over here, it's a day's worth of plan, and for any given person, for example Devon, over here you will see their plan. So they start at 8, then they have back-to-back jobs. Because their car battery is currently 100%, the entire route can be completed end to end and no battery charge or nothing will be required. But let's assume that a detour is required. Then what we will see when the AI comes up with a suggestion is something like this, where the system is going to say that, hey, a detour is required. And why? Because it's going to take, first of all, 22 minutes. This is the kilowatt per hour battery like the charging speed. And then the reason for the detour is because on the calendar, when the job is being planned, the car percentage is going to dip too low, and before doing that, you want to make sure that the car is fully charged so the person can continue throughout the day. This example is very similar to a grease trap company or a septic tap company, where the tanker's capacity, when it is full, it needs to go to a depot, it needs to empty it and then continue the route. As we have more fleets getting EV or electrified, then that means that this is going to be a must-have feature for every single business. Now if you are asking how are you going to see this on the plan, it's pretty much simple. You don't need to worry about, hey, how is this going to look on the calendar. So it just comes as a regular block on the calendar. And as you can see, this is a demo detour, but a battery park garage detour. It's an 18-minute drive and the person is going to be there for 2 hours. So that means you need to plan out and make sure that, of course, it's during the paid hours. So are those 2 hours going to be paid, or is it just going to be the technician is going to be taking a break? So you need to plan contingencies around this and what type of chargers you want your technicians to use for them to get the job done faster. While looking at all this, when you're a normal company who is using normal gas fleets, your question is, hey, what's the shortest route so we save most money on the gas? But with the EV, your question is different. Your question is, can this exact truck, starting with this exact battery, drive this exact route, stop at this charger if needed, and still finish early? That's the problem FieldCamp is solving. On the board, the dispatcher can actually read the decision. You see that EV battery status on technician's card, green, amber, red, depending on the battery level. You also see when the battery reading was last seen. On the timeline, the charging stop shows up as the part ultimately of the route, and you can see the station, how long the person is going to be, and every single thing that you need for your EV fleet to be dispatched accurately. Because overscheduling is expensive, underscheduling is losing money. You need the exact right figure, and we are taking the first step when your fleet is starting to get electrification electrification is coming inside your fleet operations, FieldCamp is taking the first step to support this. And as I said, the AI dispatcher doesn't replace an entire suite. What it does is it plugs into your existing systems to do all of this automatically, where it plans out and it pushes into, for example, Microsoft Dynamics or Salesforce, and it can sit on top of your FSM and telematics tools you already use, like Smartcar or OpenChargeMap. The dispatcher still reviews the schedule, the dispatcher still approves it, the system just does the battery aware math and all the constraints when it is planning the routes. If you want this system to be implemented for your fleet or for your HVAC business or any field operation business, we should have a talk. Of course, this is just a starting point on how we are starting, but we can customize this based on your fleet and how you think FieldCamp can fit into your picture. Thank you.